Today on Capaci's Corner, we are getting ready to start a new chapter called Exponents and Exponential Functions, and the first lesson today is on multiplication properties of exponents. The vocabulary we're going to start with is monomial, and a monomial is a number, variable, or the product of a number and one or more variables. Mono means one, so here are some examples we could have. The number 7 by itself, a number, that's a monomial. 2x, we could have a combination of a number times a variable. And then we have 3x squared y. We just have one term. We're not adding or subtracting the monomials together. Now another thing we have to remember before we get started is remember what it's like to square with a negative number or a positive number. 2 squared is equal to 4. Remember that's 2 times 2. That equals 4. Now if I have negative 2 in parentheses, it's saying take whatever is inside the parentheses and multiply it twice. So negative 2 times negative 2 gives us a positive 4. That's different than our last example down here. What this is saying is take 2 and square it, and then multiply it by negative 1. So that means take 2 squared, which is 4, multiply it by negative 1, which gives us negative 4. We're going to look at 3 different properties today. The first one is called product of powers property, and what that means is if I have the base is the same, and they're each raised to a power, I'm going to keep the base the same, and I'm actually going to add these exponents. In the power of a power property, taking a power and raising it to another power, we're going to keep the base the same, and this time we're going to multiply those exponents. And the last property we're going to look at today is called a power of a product. Remember, product means multiply property. If you have something inside parentheses, whether it's a coefficient or different variables, everything gets raised to the power. So if you have a times b all raised to the m power, you're going to take a and you're going to raise it to the m power, and you're also going to take b and raise it to the m power as well. Let's first start with the product of powers property. That saying is if the bases are the same and they're raised to the power, we're going to add those powers. Now this gets confusing because people see a multiplication symbol and don't understand why you're adding the exponents, not multiplying. So let's look at number 1. The first term is saying 5 to the third. So that really means 5 times 5 times 5. We're taking 5 and we're multiplying it 3 times. Do the same thing with 5 squared. So that's 5 times 5. Now if you add those together, I have 3 here and I have 2 here. Together I have 5, which is 5 to the 5th, which is why you add those exponents. Now it's going to be a lot easier if you just know that rule and add them together versus writing them out every time. Let's look at number 2. My base is the same, it's a. So I have a to the third times a. Now this is to the first, so if that helps me to write that there, I can. Times a to the 5th. When I add my exponents, I get 3 plus 1 plus 5, which gives me 9. So my final answer is a to the 9th. Now look at number 3. I have some coefficients there. So I have 2 times 5 times 4. So I'm going to take care of that first. So 2 times 5 gives me 10, times 4 gives me 40. Now I'm going to look at my variable. I have y to the third times y, which gives me, that's to the first power. So 3 plus 1 gives me 4, plus 7 gives me 11. So my final answer there is 40y to the 11th. Now last one, number 4. We do have negative 2 is our common base, so I'm going to leave that there. And I have 4 there, and I have a 1 here. So I have negative 2 is raised to the 5th power. So when I take negative 2 and I raise it to the 5th power, multiplying negative 2 5 times, I get negative 32. And looking at our next property, we have power of a power property. Having a base raised to a power and then raising it to another power. When we do that, we multiply. In number 1, we basically have 3 to the 5th, and we have that twice. So if I were to take 3 to the 5th times 3 to the 5th, now I'm going to go back to my rule we just did. That becomes 3 to the 10th because I'm adding those exponents. Now again, it's a lot easier if I just know the rule and say 3 is raised to the 5th power, which is raised to the 2nd power, so 5 times 2 gives me 10. In number 2, again, this is x, multiply 3 by 5, and I have x to the 15th. Now number 3, my whole base is a minus 2, so I'm going to keep that as is, that doesn't change. And then I'm multiplying 3 times 2, which gives me 6. And the last one, number 4, again, my base is negative 3. and that's raised to the third power, and then again I'm raising it to the second power. So 3 times 2 gives me 6. And when I take negative 3 and I raise it to the sixth power, meaning I multiply negative 3 6 times, I get positive 729. Now we're going to work on power of a product property. So whatever is inside the parentheses gets raised to the power. So I have a to the m and b to the m. Looking at number 1, where we're going to raise 3 to the third power. And the next, remember, this is to the first, so 1 times 3 gives me 3. The y is also to the first, so y1 then raised to the third gives me y to the third. Now I just have to clean it up a little bit. 3 to the third is 27, so it gives me 27, x to the third, y to the third. That's my final answer there. Now number 2, I have to be careful. This is negative 2 in parentheses raised to the second power. And again, this is w to the first, so 1 times 2 gives me 2. Now negative 2 to the second power is positive 4, so you have to be careful. 4w squared is my final answer. Now if you're going to happen to put that in your calculator, if it's a number that's a little bit more difficult or you're just struggling on this concept, you're going to have to put it in as exactly as it appears. So in this case, you're going to need parentheses there, negative 2, and then raise it to the second power. Now number 3, this negative sign, I'm just going to rewrite that. I'm going to come back to that because it's multiplying my answer by negative 1. So I'm going to get 4 to the third. Now I have x to the third raised to the third power. So 3 times 3 gives me 9. Same thing with y to the seventh raised to the third. 7 times 3 gives me 21. And z to the sixth raised to the third power is z to the 18th. Now this whole thing is multiplied by negative 1. 4 to the third power is 64. So I just have to multiply that by negative 1. So my final answer is negative 64, x to the 9th, y to the 21st, and z to the 18th. Now in our last few examples for today, we're going to put everything together, all the properties we've been working on today. So let's look at number 1. First I'm going to raise 4 to the third power, and then x is going to be to the 6th because 2 times 3 gives me 6, and y is to the first, so 1 times 3 gives me 3. I'm going to multiply that whole thing by x to the 5th. Now 4 to the third power is 64. Now because I'm multiplying here, I'm going to add my exponent. So I have x to the 11th, y to the 3rd. So that's my final answer for number 1. Now looking at number 2, again I have negative 9. I'm going to square that. I have k to the second, p to the second, times negative 3, p to the 4th. So negative 9 squared is positive 81. I have k to the second, p to the second, times negative 3, p to the 4th. So 81 times negative 3 is going to give me negative 243. Then I have k to the second, and now I have p to the second times p to the 4th, which gives me p to the 6th. So that'll be my final answer right there. Now last one, number 3, I have 5x squared y z to the 3rd times, now I have negative 4 squared, x to the 8th, because we take 4 times 2, power to a power, we multiply, and then y to the 12th. Now negative 4 squared gives me positive 16, so 5 times 16 gives me 80. I have x to the second and x to the 8th, which gives me x to the 10th. Y to the 1st times y to the 12th gives me y to the 13th, and z to the 3rd. So there's my final answer.